All right, on Friday, what you guys saw from the notes you took is, okay, I know I need 3 pairs of angles and sides to prove triangles congruent. On Friday, the first 2 pair came pretty easy. Third pair we struggled with a little. Now it's even going to be worse, that third pair. Where do I find that third pair from? Okay, so you guys know the deal here. Go ahead, mark your diagram, write your givens in, and we will talk after you're done.
Can I just get one of the paper packets?
Yep, we're still in the box there. That's why I save them. Okay, everyone ready to roll here? I want to get going. I know we only have 3, but they're probably going to take us most of the time. All right, let's look at the proof statement. I'm asked to prove segment TD congruent to RO. TD congruent to RO. I'm hoping at this point in the unit, since this is the second to last day of the unit, we understand that if you're going to prove 2 sides congruent, I need to prove triangles congruent first. I know at the end this is going to be CPCTC, don't I? I just got to prove triangles first. So as a class, we need to make a decision. What 2 triangles should I prove congruent that have TD and RO as sides? And you actually have some choices here, but I want to make the same decision as a class. I could prove triangle TDE congruent to triangle IOR. They both have RO and TD. That's an option, right? Everyone's good if I can prove them? Those are sides, CPCTC. There's another option, though. I could do those 2. So first, before I erase this, take a look at what you have right now. You have a pair of sides in those 2 triangles, right? A pair of sides. All right, that's it. Let me highlight or you guys can tell me, what are the other pair of triangles I could prove congruent and still get TD and RO congruent? Where are my other 2 triangles up here that contain TD and RO? Name another pair that contain them. Let's go deep. Emma, go ahead. Name another pair that contain TD and RO that might be choices.
Triangle TIO and triangle RDE.
Good job. These bottom ones here. ROE. ROE. Yep. Everyone see those 2? I could do those 2. Well, what do I know about those 2? I got a pair of sides, and what else do I have? The right angles. So doesn't it seem like I have a little bit more information on these 2 right here than the first 2? So why don't we try to prove those 2 congruent right now? Everyone on board with the plan? Why I'm proving those 2 versus the original 2 I showed you. I just have more information. All right, so I have a pair of sides already. I gave you guys a pair of sides in IT and ER. So I gave you a pair of sides. Still need to say what, though, so I can get a pair of angles. What do I still need to say? 14. Here we go. Ellie, what do I still need to say to get a pair of angles? Good job, Ellie. Here we go. Angle TDI. Congruent to angle ROE. All right angles congruent. All right. Not too bad so far, right? This was supposed to be a tough day, and I already have 2 pairs. Yeah, 2 pairs. 1 more to go, and we're good. 1 more. I'll let you look. I'll let you look. Where's that other pair going to come from? And if anybody's thinking this, I just want to throw this away right now. If anybody's thinking, oh, you have alternate interior angles, they're congruent. I need parallel lines. Out. I don't have parallel lines. Good thinking, though. Great thinking. I just don't have parallel lines. If you got anything, I'd love to hear it.
Can you use hypotenuse leg?
Where's your leg? You have the hypotenuse. Hypotenuse is T-I-N-E-R. I just don't have a leg. All right, good thinking. I want to hear everything here, guys. What you're thinking. Anything else, Quincy?
Does EI have to be in like a, has it, you know how it says like line in the given sometimes?
Yep.
Would it have to be that to say supplementary angle?
Where are you going with supplementary here?
Oh, that would work. I don't know why I thought that.
The only supplementaries are here and here, right? And then now I'm getting outside of my triangle that I need.
Yeah.
Guys, it's okay because there is nothing. You're not doing it. There is not a third piece here yet. There's not a third piece to say the triangles are congruent. I'm sorry. I appreciate all the time you just put in there trying to find it and all the suggestions, but there's not a third piece. So unfortunately, we're going to have to get back to those triangles. All right, everybody good? There is no third piece right now. Yet, anyway. So let's get off these two triangles, and can anybody find another pair on here that we could prove congruent right now? Anybody see another pair of triangles that you could confidently say, if we did this, yeah, they'd be congruent? Do we see that? We don't have enough to prove the original pair. Okay, I'll get over it, I guess. Get over it, right? Can we find a new pair that are congruent? Sinjin.
Triangle ETI and IRE.
Everyone see the two big ones. TEI and IER. You already have two pairs of sides, and what's everyone else see as well? Between these two triangles, you have two pairs of sides, and what else could you say on your own? Oh boy. Everyone see the triangles we're talking about. TEI and IER. These two big ones right on top of each other. You have the two sides, and what else do they share? A side, a reflexive side, which we'll put in right now. EI congruent to EI. Reflexive. Now you can, and you're probably wondering, why would you ever want to prove those triangles? You'll see, it'll all come together. So now we can say triangle TEI is congruent to triangle, let's see, if I go TEI, I got to go RIE. How's that sound, guys? That looks like it matches up. By what method? Maeve, what method are those two equal?
Side, side, side.
Great job, Maeve. Side, side, side. All right. What the heck did we just do that for? Well, we just want to look smarter, make our proof a little longer because we got stuck at the other two triangles? All right, why did I just prove those triangles congruent? Here's why. Here's why you just proved the triangles congruent in step 4. Now that they're congruent, aren't all their angles and sides equal too? Let me say that again. If those two triangles are equal, aren't all their angles and sides equal? Yeah. Everyone, look at their angles and sides in those two big triangles. Is there anything maybe I could use in the triangles I'm trying to get congruent? Anybody see a pair of angles or a pair of sides that are in the triangles I just proved congruent and the ones I'm trying to prove? Do you guys see any angles or sides that are contained in both sets of triangles? You should. I'll give people a second, and then Gideon, you're going to take over. But everyone else, take a look at my diagram. Take a look at your diagram. Anybody see any angles in the side, side, side triangles or sides that are also used in the triangles I got stuck on? Because that's going to be my third and final missing piece. Gideon, got anything?
IER and EIT.
Angles you're talking, I assume?
Yep.
Okay, everybody, take a look right now. Let's see. Pink, sure. Everyone see this angle right here? Angle IER. That's in the pair of big, the side, side, side triangles. And so are TIO. They have to be congruent by CPCTC because they're in my side, side, side triangles. Everyone see that? And guess what that gives me? The missing link, right? That was the missing pair I needed. We were so stuck on a missing pair to prove the original two triangles, we just found it by proving another pair congruent. And that's what you're going to have to get used to. You're going to be stuck today, so get off the triangles you need and try to find another pair to help you out. So angle TIE congruent to angle IER, and you can name these a couple different ways. All right, that's not the only way to name them, by CPCTC, because those were angles in my side triangles. And again, look, there it is. There was my missing pair. There's my missing pair. See how I got it? And now you can say triangle TID congruent to, oh boy, kids, if I go TID,
I think it's REO.
R, it looks like REO for, yep.
Is it fine that for the previous step, I just wrote, I guess it was. Oh, never mind. I just wasn't sure whether the wording for the angle was right.
There's a couple, like I did the whole thing. I did TIE, you can go TID
TIE and.
or TIO, it's the same angle. What method here now? What method for those two triangles? Here we go. Ellie, what method we got there? Good job. The side is not in between there. Good. And then why did I prove the triangles congruent? So we could eventually get to TD being congruent to RO by CPCTC. So everyone see? Yes, Gideon.
So do you even need the right angles? Because you could do side by.
How? Whoa. For these two, where's side, you would need TD congruent to RO, which I'm trying to prove.
But,
Where's side coming in these two triangles?
Couldn't you do DI and EO by reflexive and addition?
DI and EO. But you would need E. Here's what you're going to write. You're going to write ED plus DO, right? Equals OI plus DO.
Yeah.
How many pairs of equal quantities do you need to subtract? To add. You need two pair, don't you? Yeah, I know DO and DO are equal, but these pair have to be equal too. All right, I just can't add anything I want. I know what I'm adding need to be congruent to each other, which is not the case there. So I did need the right angles. Okay, everyone, anybody at home? Yep, go ahead, Hannah. I'm ready.
So this could be a long shot, but okay. So you do have to step 3 the same, and then couldn't you do DO congruent to DO, and then do EI minus DO equals EI minus DO?
You can't. No, if you can't subtract two reflexives together. Here's exactly why. Ready? Just let me show you, and it's a great question. All right, very good question. Okay, Hannah. Let's say EI is 10 units long. Okay, EI is 10 units long. And DO is 6 units long. So you have 4 left, right? That doesn't necessarily mean that EO and ID are going to be 2 and 2. Could be 3 and 1. Okay? It's just not, you can't do that with 2 reflexives. All right? No adding and subtracting with 2 reflexives. All right? Anybody else? Questions?
I found my homework.
Okay. I want to finish teaching. That'd be great. Everybody else? Okay, so probably where you're going to get that third pair from today? Proving another pair of triangles congruent to say CPCTC. Let's keep trucking. If you haven't already, go ahead, set it up. You guys are doing a nice job today. A lot of great questions. You cannot add or subtract with 2 reflexives. Also, I don't know if it came up in this class or one of my other honors classes, you cannot add or subtract triangles either. Okay, you can only add and subtract sides and angles. There's no such thing as a reflexive triangle. Only sides and angles. It sounds funny, but kids try it out. They try to test it. All right away, I tell you what 2 triangles I need. QET. And I'm also going to need QEU in the house here. Boom. All right, what did I already give you? Just handed it to you here. What do you already know? Oh, and what do we already know? About those two triangles.
An angle.
Yep, 3 and 4. Gave you guys an angle. What else can you mark on your diagram? I'm going to go quick through this. We're almost done with this unit. Atticus, what else can you mark on the diagram? About those two triangles, Atticus, what can I also mark on the diagram?
QE's reflexive.
There we go. I got QE equal to QE. There's another side. It makes you feel warm inside, doesn't it? You're like, oh, I already got two things down, and then all of a sudden it comes to a screeching halt. All right, anything else you want to talk to me about? I'd love to discuss it. Don't tell me right angles. You don't have perpendicular lines up there. You could tell me vertical angles, but one will be in the triangle, one won't be in the triangle, so that's out. Gideon?
You could do the Q.
No, I don't even want to know that yet. I'm just looking for things in these two triangles. Anybody see any other parts you could prove congruent in those two triangles? We're asked to prove congruent. Anybody else going? And again, that's okay. That's what's probably going to happen today. That's okay if you get stuck because it's not happening. There is no third pair to prove congruent. So we have to just calmly get over it, right? Calmly get over it and say, are there any other triangles maybe I can now prove congruent? Hopefully there will be. Anybody see any other triangles? Go ahead, Gideon. What other two triangles can I prove congruent?
QUB and BTQ.
Say that again.
QUB and BTQ.
There you go. The big one on top and the big one on the bottom. QTB, QUB. I already have two pairs of angles. What's the other pair that's going to make them congruent? I already have two pairs of angles here. What's the other pair that's going to make those two triangles congruent? What else do I need to say still? Radhika, what else do I still need to say to make those two triangles congruent? QTB and QUB. One job, Radhika. Her audio went out, quote unquote. 15. Now Will's going to have to take it on. Will, what else do I need before I prove these two big dogs congruent?
There's a reflexive side QB.
Yes, QB. I'll just put it in step 2, but if you guys want to make a step 3 to make your proof longer so you seem smarter, go right ahead. Just joking. Just joking.
Can you also you try and prove? First one I saw was QUT and BTU.
How?
That's what I'm not sure of.
Me neither.
Is it possible? No. Okay.
We good? All right. I'm all for listening to
It's
it.
just first one I saw, and I thought that maybe you could do something with, like, I don't know, the two angles are congruent there for that implies bisector or something.
No, you're making up your Sophia theorems again. All right.
I have another Sophia.
Triangle QTB congruent to triangle QUB. Oh, need a method. Luke, need a method.
Angle side.
All right, there we go. All right, we just don't prove those two triangles just to make our proofs longer. We prove those two triangles congruent so we could steal some of their angles or sides. What angles or sides are going to be useful in those two triangles to help me finish this proof? Look through it. This is the toughest part about today, by far for kids. Toughest part is finding the sides or angles from one pair of triangles that will help me in another pair. Where are the sides or angles in QTB and QUB that will help me in the proved triangles? Got it, Luke? Yes?
QU and QT.
QU, everyone, yes. Take a look as we do it all together. QU, full side in both, and QT, full side in both. Everyone see those? It might be a struggle, I know. This is the toughest part about today. QU, congruent to QT. Why are those two equal? CPCTC. They're in the triangles we just proved congruent by angle, side, angle. And look what that gave us, kids. The missing link, the third and final pair we needed to now say triangle QET congruent to triangle QEU. Yeah. By this method, not angle, side, angle, but by Sophia.
Oh, in this case, it'd be SAS.
Yes, it would be side, angle, side. Let's go. Other comments here before we get to the last one. Other comments you want to make? You look at it, it's 5 steps, and you're like, big deal, right? But as we can see today, that third pair is a challenge.
Could you get congruent TD by doing the inner triangle, congruent angles or across, or congruent sides or across from congruent angles?
Okay, how did you just say that first part? In a triangle. Where are those 2 angles located? 2 different triangles. You see that? I cannot use that theorem unless both angles are in the same triangle. Do you see how the angle 3 is in triangle TQE and angle 4 is in EQU? They got to be in the same one. Okay, got to be in the same one. I see what you're trying to do, but they got to be in the same one. And then here it is. Let's go. Let's finish. Finish. We're not playing around here. And yes, if anybody's wondering, you got a test on Thursday or Friday. There will be one of these proofs on there, yes. 8 points. We made it.
Did you figure out whether there would be factoring or not?
No factoring. You can thank me later. No factoring.
Thank you.
But 3 proofs. One of them, the caliber we're doing today. All right, doesn't look too bad. Look at those triangles. They're nice, huh? They don't look that bad. I did not give you any congruent sides or angles, but I did give you AC and BD bisect each other. Your turn. Conclusion. What do you got for me? If AC and BD bisect each other, where are we? What's true? Oh, gee. Sophia, here we go.
DGC and BGA are congruent in vertical angles.
Say that one more time.
DGC and BGA are congruent.
Oh, look, you didn't even use the givens yet, huh? That's fine.
Oh.
No, actually, okay, I'm just going to write it down and then talk about it because you just you rattled me there. That doesn't happen often. DGC congruent to AGB. A lot of people don't see that. That's why I got thrown off a little bit. A lot of people don't see that. All right, if it helps, ready? Watch this. Watch my magician here, my magic act. If I just get rid of this vertical line here, everyone see the vertical angles now? Okay? A lot of people can't get past those vertical lines and don't see the vertical angles. So Sophia just helped you guys out tremendously. Vertical angles are congruent. She just gave you a tough pair of angles to find. All right, still haven't used the givens yet. And AC and BD bisect each other. What do you got from there? What else can you tell me is true? Boom, 17. Maeve, here you go, Maeve.
DG is congruent to GB, and CG is congruent to GF.
There you go. Both those are equal because they bisect each other. They cut each other in half. DG congruent to GB, and GA congruent to GC. Definition of bisects. Job, Maeve. Guys, what's happening here? What do we know now? Yeah. I don't got to get sneaky here. They're congruent. There's no missing third pair on this one. Oh, you wait. You think you're smooth sailing. But I do need a reason why the triangles are congruent then if you're going to tell me they are. Woo, here we go. What do you got, Vinny? There you go, boss. Side angle side. That wasn't bad. Oh, but it's too bad there's a second part, huh? Oh! How am I going to get line segment GE congruent to GF? This will help me know that you understand this concept. Can I just say step 5, they're congruent by CPCTC? Anybody at home? Can I just say step 5, those two are congruent, CPCTC? No! CPCTC is only for sides and angles in the triangles we just proved congruent. And GE and GF, sorry to say, they're not in those triangles we just proved congruent. We need to get them congruent, though. All right. Guys, second to last day of the unit, right? How have we been getting sides congruent? Prove what first? Triangles congruent. I don't need the triangles I just proved, though. Can somebody give me a pair of triangles? Because there's multiple pair up here. I'm going to ask somebody. We're going to do the same way as the class. Can somebody name 2 triangles that contain GE and GF that you think you can prove congruent? There's a bunch here. There's a bunch. Quincy?
GCE and GAF.
Okay, let me highlight those that he just told me real quick. Everyone, he said, let's do GCE and let's do GAF. I got those right, Quincy? You could have also proved the other pair I didn't highlight. Okay, if you didn't want Quincy's pair, you could have done DEG and GFB, the other pair I didn't highlight in red. All right, let's do it. Let's try to get them congruent. I already have a pair of sides. What else you guys got for me? I already have a pair of sides congruent. I need others, though. What else can you tell me is true about those triangles? Ooh, this is going to be a tough one. Come on now. Hi, Ryan. Anything else you can tell me true?
Can you say EF is congruent to EF?
Okay, is EF a side in this triangle? Not a full side. Okay, so you can't tell me that. Because EF is, like, it combines 2 sides, but it's not a full side in both. I need full sides or full angles.
Could you say angle? I'm not sure.
Go ahead, say what you're going to say.
Angle AGB.
AG.
AGF
Yep.
is congruent to angle FGC because of definition of bisect.
Not by bisects. You got the right angles. You told me the correct angles. Ready? AGF and EGC. What type of angles are those?
Vertical.
Yeah. Good.
Sure.
But can't use bisects, Ryan, because the sides were getting bisected, not the angles. Everyone see Ryan's vertical angles. Nice job. But yeah, if you guys want to add that in step 2, you can. I want to make myself look smart and my proof a little longer, so I'll put it in step 5. AGF congruent to angle, what was it got? EGC. Vertical angles are congruent. Good job. Okay, everyone see those that Ryan gave us right here, this vert and this vert? Okay, I need one more pair. This is tough. One more pair of angles or sides. This is tough. Where is the other pair of angles or sides? And just a reminder what we did in step 4. Didn't we just prove triangles congruent? So every little piece about those triangles are equal as well? Could that help us? Knowing the 2 big triangles are congruent, could that help us finding a missing angle or sides right now? Was that a paw going up, Omni?
Yeah, sure. Angle A is congruent to angle C.
Everyone look at angle A and C, please. See how it's contained in the 2 triangles that are already congruent and also the ones we're looking for. Good job, Omni. Everyone at home see that? Angle A and angle C are in both. They have to be congruent by CPCTC. Now the triangles Quincy gave us are now congruent. That was tough right there, finding A and C. Triangle DGC. I should be asking you guys this, but let's see if I go D, and I totally messed up that triangle anyway. One job, Mr. Carlino, come on. Act like you've been here. EGC. Triangle EGC. All right, kids, if I go EGC, what do you got for me? What's going to match up with EGC? FGA. And then now I'm going to ask somebody, how about a method? How about a method for those two? Hannah, what do you got for a method?
Angle, side angle.
Good job, Hannah. Angle, side angle, and then you guys can finish it off. GE and GF coming together. CPCT, C. Okay. Go ahead, start those next proofs, guys. You're gonna have to, you do not quit. You know that in here. We do not quit in an honors level math course. All right, all my solutions are up on Classroom. All right, I prefer you not to copy them, but just use them in case you get stuck. All right, let's go. Here we go. No quitting here. If you get stuck, find another pair of triangles. That's no big deal.